Hey, what is up, guys? Welcome back to Code with Nani channel. Today we're gonna discuss about placement related problems. So these are the problems that is repeatedly asking in the interviews, companies like TCS, Accenture, Wipro, and some other dream companies. So let's get into this video. So as we have discussed pattern problems, reversing, and palindrome in your previous videos, let's discuss Armstrong numbers, factorial number, Fibonacci, and prime numbers. So first one, Armstrong numbers. So what is an Armstrong number? So Armstrong number is a number when it is cubed on each digit, it still be equal to the same digit. For example, let's take number 153. So when you cube each digit of this particular number, still it gives 153. Like 3 cube plus 5 cube plus 1 cube. So 3 cube 27, 5 cube 125 plus 1. So still it gives 153. So even if you cube the each digit of this particular number, still it is giving the same number. So that is called a Armstrong number. So how do we code this, guys? So how do you code this? So let's think about the same approach as we did on the last digit. So what we are doing here is just extract the final last digit, cube the last digit with the same number, then store it in the result. So by that, iterate over each and every digit and cube the each digit and add it to the result. That's how we're gonna do. So I'll write this piece of code. While n greater than 0, LD int LD is equal to n percentage 10. So why we are writing this? To extract the last digit. Then make LD is equal to LD into LD into LD, which means we are cubing the last digit. Now store RT is equal to RT plus LD, which we are storing each digit value with the previous result value. Like let's say if the right now, like let's dry run this program. So whenever the number is 153, as n is greater than 0, then LD will extract the last digit 3. How does the LD works? LD works till will extract the last digit, then LD is equal to 3 cube, and what we are showing in the result, 0 plus 3 cube, that is 27. So in the next iteration we will go through, like sorry to mention about this. Now make n equal to n by 10. Why we are writing this piece of code? Because we don't need to iterate over the same number, we don't need to stuck on the same number, right? If we don't delete this digit, we'll still be extracting 3 and we'll continue to be looping over this digit. So what we are doing, executing this. Now LD becomes 5, now this becomes 5 cube, and what we are doing is adding 5 cube, adding last digit cube over the previous result of the digit. I'm adding 5 cube. So that's how the code works. Let's get into this implementation of this code. Let's get into Sublime. Guys, still if you don't install Sublime on your local machine, just check out my DSA playlist. There you will find how do you install Sublime on your local machine. Just do check it out and install on your local machine. The same code, just taking the input, then int ans is equal to n. Because why we are writing ans equal to n, because at the final we have to compare this Armstrong number, that which we returned as the result. Because if you don't do after the iteration of the while loop, it becomes 0. So that's why we are storing that n value before. I'll show you example. Right now, after the completing of this loop, n value becomes 0. So at the end we have to compare RT with the n value. That's why storing the answer variable with the same n value. Now get in n greater than 0 and int last digit is equal to n percentage 10 modulo 10, and we're cubing this number LD into LD into LD. And what we are doing, RT plus is equal to LD. Let's say RT is equal to RT plus LD. If ans is equal to N, C out Armstrong number. Else, C out. It is not. So let's initialize result equal to 0. Let's run this. Let's give the input as 153. Movie. Let's give 153. So, oh yeah, sorry to mention this. Forget to divide the value with 10 because it still be looping on infinite loop, right? So never make the same mistake which I did. Let's see. Why? Not is equal to RD. Okay. I think we got some error. Starting cubing. Plus LD and equal to M by 10. Sorry guys. We are storing the RT variable, so that's the mistake I did. Now that's done, right? Yeah. 153 Armstrong number. Let's choose another variable. Let's say 152. It is not an Armstrong number. Yeah, it is not an Armstrong number. So let's guess another problem. So now let's discuss about factorial number. So what is a factorial number? So factorial number is like multiplication of a number from I equal to 1 to that particular number. Like let's say if you take a value 5, so we'll be multiplying from I equal to 1 to I less than or equal to 5. So what is the value of the 5 factorial? It's 120. So we'll do the same thing. Like if you take a 5 factorial, what is that meaning of a 5 factorial? 5 into 4 into 3 into 2 into 1. So let's take in this case, what is it means? 1 into 2 into 3 into 4 into 5. So what we are doing, looping from I equal to 1 to I less than or equal to n, because here n value is 5. So that's how it does. So we'll just keep a track of the variable ans and we'll just multiply with the ans into I. That's it. So we'll get the output. Let's show you the code. Let's take an value of n for int I is equal to 1, I less than or equal to n, because we need to include 5 as well. That is why we are making it I less than or equal to n. And I plus plus. Let's take answer as. Be careful, guys. We are initializing answer with 1 because why? Because suppose if you initialize ans with 0, anything that is multiplied with 0 is 0, still be 0. So we don't get a valid answer. So that's why we are initializing ans with a 1, so that whenever the new value is multiplied with answer, it still returns the same answer, still written with the value. So now answer is equal to answer into I, because we had to multiply with that ith iteration. Suppose if now answer is 1, so we are multiplying with ans is equal to ans into I. Now becomes 1 into 1 1, now becomes 1 into 2, now becomes 2 into 3 6, now 6 into 4 24, now 24 into 5 120. So what is the value of 5 factorial? 120. So that's how algorithm works. Let's get into the implementation video. Now just print out ans. Now let's inline it. Let's give the input. New test case. Let's delete all test cases. Or else give this 5 factorial 120. What is 7 factorial? or 40. So that's how factorial code works. Now let's get into another problem. Fibonacci series. So what is Fibonacci series? So Fibonacci series is nothing but we are adding over the third variable with the previous two values and printing that third variable. So we keep on repeating the same thing until it reaches the n values, nth step. Suppose we want first 5 terms of a Fibonacci series. So it started with the first number 0 and next number is 1, and the next term, which is the third term, will be adding these two terms, 0 plus 1. The third term will be 1, and then t2 and t1 will swap the variables. So I'll give an example, then you will get clear about everything, what's the behind thing. So how this Fibonacci series? Now Fibonacci series starts with the t1. So t1 equal to 0, t2 becomes 1. Now Fibonacci series starts with 0, 1. And what is the third variable? t3. t3 is adding of these two values. So 0 plus 1, 1. This is t1, this is t2, right? So now how about t4? t4 is the adding of the previous two values, these two values. So 1 plus 1, 2. What is t5? Adding of these two previous values. 1 plus 2, 3. What is t6? Addition of previous two values, 2 and 3. Fine. So that's how the Fibonacci series continues. So how do we approach this type of problems? So let's make a two pointers, t1 and t2, right? t1 is equal to 0, t2 equal to 1, and t3 is equal to t1 plus t2. So thus we are printing this right now. So we're printing t1 0, t2 is 1, and now what is t3? t1 plus t2, 0 plus 1, 1. Now this is t3, this is t1, t2, and this is t1, right? So now what we are doing is swapping of the t1 and t2. Now this becomes t2 and this becomes t1. So that adding of these two values will give the t3 value. What is t3 value? 2. Now how it becomes now? Now this becomes t2 and this becomes t1. So the values of t1 and t2 will keep on swapping. So the current t3 value becomes t2 and the previous t2 value becomes t1. So that's how we are like adding these two statements for the next t3 value. 3. Now this becomes t2. Current t3 value becomes t2 and the previous t2 value becomes t1, and we will add these two. 2 plus 3, 5. That's how the Fibonacci series continues until the term reaches. Like if I ask for 5 terms, 1, 2, 3, 4, 5. So we got 5 terms. So ask for 6th term, we have 6th term. So until the nth term, we keep on swapping the t1 and t2, and we'll get the t3 value. So the code goes like this: t1 equal to 0, t2 equal to 1. See out, because we have to print this t1 and t2, right? 0 for int I is equal to 0, I less than n minus 2. Why we are writing n minus 2? Because we already printed t1 and t2. We already included two terms. So if you say n minus 2, that is why, because we already included two terms. That's why we are subtracting from the n minus 2 terms. I plus plus. So now what will happen? t3 int t3 is equal to t1 plus t2, and we will print that t3 value. Now we have to swap the values. Now t2 becomes current t3 value, and t1 becomes, and what the t1 becomes? t1 becomes t2 value. That's how the new value will be generated. So now current value becomes t2 and the previous value becomes t1, and we'll add both the values and we'll generate T3 and we'll print that T3. That how the loop continues until n minus 2 terms, because we already printed T1 and T2. So only the two terms printed, that's why we are looping until n minus 2. Let's get into the implementation video, then you'll get to know about it. Everything. So let's take int T1 equals 0 and T2 is equal to 1. Let's print out these two terms because it all starts from T1 and T2, right? Let's give them a space and T2. Also give the space for those two terms. Now what we have to do? Loop until n minus 2 terms. 0 I less than n minus 2 terms, right? I plus plus let's take the third variable T3 is equal to T1 plus T2. Let's print this T3 value as well. And also now what we have to do, let us swap the current value and previous value. Now what the T2 value becomes present current value, and what is the T1 value becomes previous T2 value. That's it. Let's run this. After everything is done, let's give an end line, run it. So let's give input as 8 terms, right? See, we got 8 terms, 3, 6, 7, 8. So we got 8 terms of the Fibonacci series, first 8 terms. Let's give another input 5. We got 5 numbers. So that's how a Fibonacci series works. Let's get into another problem. So these are the most repeatedly asked in interviews. So do concentrate on this problem. If you had any query regarding any problem, just do write in the comment section and I'll help you out. So let's get into another problem. Let's see what's next. Let's see what is up, guys. And the last one is prime numbers. So what is a prime number? So prime number is basically, it only has the two factors, which is 1 and itself. So it doesn't have any other factors other than this 1 and itself. Suppose we have an 21. What is the factors of 21? It is divisible by 1. It is divisible 121 as well. And what are the other factors? It is divisible by 3. It is divisible by 7. So it has more than two factors other than 1 and itself. So it is not a prime number because it is divisible by some other numbers as well. So if let's take an example 11. It is only divisible by 1 and 11. So there is no other number which can divide the 11 and gives remainder 0. So that is why it is a prime number. So how do we write the prime number? So take the same case. Just iterate. As we know, 1 and itself can always divisible by that number. So let's exclude those two numbers. So iterate from I is equal to 2 I less than n, because n value can always divisible by that number. So that's why we are incrementing until n minus 1th number. So iterate over that number, right? So when we say that this number is divisible by particular number, when it gives remainder 0, then it is divisible by that number. So if that n gives remainder by that number, like it will check for 2, 3, 4, 5 until 21. If that particular number can able to divide that n number and gives remainder 0, then if even each number, if one number can able to do that, then it is not a prime. So then it is not a prime. Simply break that statement and write C out. It is not a prime. It is not a prime, right? If none of that number is divisible by that other than 1 and itself, then it is a prime. So we can simply write prime number. right? Right? Let's get into the implementation video. Let's check int n cnn for int I is equal to 2, I less than n, I plus plus. So if n divided by I is equal to 0, what I'm doing is I'm saving this on a some other variable. Let's say int flag equals 0. I'm making flag as 0. Like let's check flag as 1. If any number can able to give the remainder 0, then make flag is equal to 0. So what does it mean? What I'm doing is I'm keep tracking of this variable, keep tracking of the status of the prime numbers. So first I'm making flag equal to 1, right? Which means I'm considering every number is a prime number. So whenever that particular number is divisible by 2, I'm making no, it is not a prime. That's why I'm making it a 0. Why I'm doing this? Because if you make a statements here C out, so for each number, for each iteration, whenever like it is divisible by 2, if it is not divisible by 3, 4, for each number, for each condition of this Boolean expression, it is going to print this thing. But we are not considering that thing, because we only need the result at the end. We don't need result in the intermediate step, because in the end it should give whether it is a prime or it is not a prime, right? So that's why in order to get rid of intermediate printing of for every number, so we are making a flag variable. So what we are storing the status of a prime. So if whenever a number is divisible by with another number and gives a remainder 0, we're making it as a flag equal to 0, which means it is not a prime number. That's what we are storing for the flag variable. So then what we are doing is then we are making a flag equal to 0. Suppose after this loop, if none of the number is divisible by that n value, then which means flag is still be 1, which means it is a prime number, right? So if flag equal to 1, which means its status still be the same, which means still it is a prime number, then what we are printing? See how it is a prime number. Else, see how it is not a prime, right? I guess that's how we implement the prime number program. So what we are doing is we keep a track of the progress of the prime number using a flag variable, and if any number is divisible by can able to give remainder 0 with that n number, so we keep the status as a 0 for that in that part of flag variable. So whenever this flag is still be a prime, assuming flag 1 is a prime, so if still it is a 1, then we are going to print out the statement as it is a prime number. Otherwise we are making, because we change the status to 0, so then it is not a prime number. So that's how the prime number program works. So if you like the video, do subscribe to my channel, share it to your friends, and if you don't want to miss any updates on my channel, just hit that like button. Thank you. Bye bye. See you tomorrow with a new great content. Bye bye. See you guys tomorrow.